Hello everyone, so we are now on the chapter 2 of the differential equation, which is all about the solution of some first order first degree. So this chapter includes the variable separable, the homogeneous, exact, linear, equation linear in a function, and the Bernoullis. For today, we are only going to discuss about the variable separable. So the definition for the variable separable is if the right hand of the equation can be expressed as this equation, wherein the left side is dy over dx equal to the function of xy, or if it could be expressed as dy over dx equal to the function of gx and function hy, we can say that it is a differential equation which can be solved by variable separable. So, as a product of a function that depends only on x and a function that depends only on y, then the differential equation is called variable separable. So, there are several steps in solving for variable separable for differential equation. So, we have to rewrite the differential equation in the form of dy over dx equal to the function of gx function of hy. And then group the x with the dx and y with the dy. And lastly, we need to integrate the differential equation. Hence, the result is the solution of the differential equation. So for example 1, we have this equation. So that is xy raised to 3 ln x dx minus 2 dy is equal to 0. So we need to rewrite the differential equation in the form of dy over dx equal to the function of gx function of hy. So this is the given example. So we need to divide the equation with the divisor that will let you have a form of dy over dx. So in order to get that dy over dx form, we need to divide both sides by 2 dx. So dividing both sides by 2 dx gives us the equation that xy raised to 3 ln x dx over 2 dx minus 2 dy over 2 dx equal to 0. Now, let us divide both sides. That will give us xy raised to 3 ln x over 2 minus dy over dx equal to 0. So we now have the form of dy over dx. So we just need to manipulate the equation in order to rewrite the form into dy over dx equal to the function gx gy. So the final answer for the step 1 is dy over dx equal to xy raised to 3 ln x over 2. Let us proceed now to the next. So we have already proved that this equation can be solved by variable separable. So we can now move on to the next step, which is to group the x with the dx and y with the dy. So we have this equation, dy over dx equal to xy raised to 3 ln x over 2. Group x with dx and y with dy, it gives us x ln x dx minus 2y raised to negative 3 dy is equal to 0. So it's now time to integrate the differential equation. So integrate the differential equation to get the solution of the differential equation. So let us integrate. So let us first integrate the one with the blue circle. So integrate the x ln x dx. So to integrate this, we need to use integration by parts, which is the formula that the integral of u dv is equal to uv minus the integral of v du. So take note that we need to choose u by this order LIATE, which means logs, inverse, algebraic, trig, exponential. So we need to choose first log if there is log, and then inverse, algebraic, trig, exponential. So the priority is in the order of LIATE. So now, do we have a log in that problem? Yes, the ln x. So we need to choose ln x as our u. And that gives us dv as x dx. So in the formula for integral by parts, we also need the du and the v. So du of u is du is equal to 1 over x dx, while the v is equal to x raised to 2 over 2. Now, let us solve for the integral of x ln x dx by the use of integral by parts. So having this u, du, dv, and v, we need to substitute it to the formula of integral by parts. So that gives us x raised to 2 over 2 times ln x minus the integral of x squared over 2 times 1 over x dx. So that gives us first that x raised to 2 over 2 ln x minus 1 half the integral of x raised to 2 over x dx. So we can take out the constant 1 half into the integral of the x squared over 2 times 1 over x dx. So that gives us this equation. Now, we can also divide x squared by x divided by x. So that gives us the equation x raised to 2 over 2 times ln x minus 1 half the integral of x dx. Now, we can really solve for the integral of x dx. So by the use of power rule, we now have x raised to 2 over 2 ln x minus 1 half times x raised to 2 over 2, in which we can multiply the denominator 2 times 2. That gives us this equation that x raised to 2 over 2 ln x minus x raised to 2 over 4. So we are done with the integration of x ln x dx. We can now proceed to the next part. So let us integrate the 2y raised to negative 3 dy. So in order to integrate this, we just need to use the power formula. So this is the power formula. So you can see it on your screen, and I know you are very familiar with this formula. So by substituting, you have this equation. And solving, you will have 2 over negative 2 times y raised to negative 2, with arriving in the final answer that the integration of your 2y raised to 3 dy is equal to negative y raised to negative 2. So the integration of that is seen on your screen. So we have already integrated the x ln x dx and the 2y raised to negative 3 dy. So that gives us the solution that x raised to 2 over 2 times ln x minus x raised to 2 over 4 minus negative y raised to 2 is equal to c. So, is that the final answer? Of course not. So, as you can see, we can still multiply this. So, that gives us a positive y raised to negative 2 is equal to c. So, to eliminate the fraction, we can also multiply the equation by 4. So, multiplying by 4, we arrive with this equation. But remember that any constant multiplied by the arbitrary constant can be still c. So even if you multiply 4 by c, that will still give you an answer of an arbitrary constant c, still c. So the final answer will be x raised to 2 times 2 ln x minus 1 plus 4y raised to negative 2 is equal to c. So take note that I did simplify this part since they have both x raised to 2. So I take out the common x squared. So that ends up giving me x raised to 2 times 2 ln x minus 1. So this is the general solution for the first example. So now let's have the example number 2. So for example number 2, we have 4 plus e raised to 2x times y prime is equal to ye raised to 2x. So note, let us assume that we already proved that the example can be solved through variable separable. So let us now proceed to the second step. So we just need to group the x with the dx and y with the dy. So we have this equation and we know that the y prime is also equal to dy over dx. Now let us separate x and x dx with y dy. So it gives us this equation. Dy over y is equal to e raised to negative 2. E raised to 2x dx over 4 plus e raised to 2x. So for the final answer for the second step, that gives us that e raised to 2x dx over 4 plus e raised to 2x minus dy over y is equal to 0. So it's now time to integrate the differential equation. So let us integrate the e raised to 2x dx over 4 plus e 2x. So what have you observed? So observing the given, we can say that we can integrate through the formula of logarithm. So the formula of logarithm is the integral of du over u is equal to ln u plus c. So it is very important that you remember how to integrate and the fundamental formulas thereof. Because if the given can be solved directly, although you know that it can be solved directly, if you do not know the fundamental formula, you will not be able to answer. So I want you to recall and review your integral so that you can answer the problems. So by the formula of logarithm, we have 1 half ln of 4 plus e raised to 2x as the answer. So for the next, dy over y, this is also can be solved by the formula of logarithm. So that gives you ln y. So now, let's go to the solution. So this is the solution for the example, but this is not yet the final solution. So to eliminate the fraction to the equation, we can multiply both sides by 2. So multiplying both sides by 2, that gives us this equation that ln of 4 plus e raised to 2x minus 2 ln y is equal to c. So, bakit 2c? Bakit c lang instead of 2c? That because, sabi ko nga kanina, anything multiplied with an arbitrary constant will still give you an arbitrary constant. So next, we can still simplify the answer. So we can eliminate the ln in the equation by taking the c as ln c. So by taking c as ln c, we have this equation. Now, By properties of logarithm, you can also express the 2 ln y to ln y raised to 2. So expressing the 2 ln y to ln y raised to 2, that gives us this equation. And then, by properties of logarithm, you can also express the equation as this. So I want you to recall properties of logarithm on why this equation turns into this equation. So I hope some of you remember this property of logarithm because it is a very important tool in solving or simplifying problems. So next, to finally eliminate the ln in the equation, let the equation be the power of e to use the property of logarithm that e raised to ln x is equal to x. So this will be the equation. Using the equation as a power of e, we arrive with this equation. So by property of logarithm, we will have this answer that 4 plus e raised to 2x divided by y raised to 2 is equal to c. And that gives us a final answer that 4 plus e raised to 2x equal to cy raised to 2. So that is the general solution for the example number 2. So read more in the reference for additional examples. So my reference is still the book of J. Perante, W. Perante, and F. Gumba, copyrighted 2014, entitled Differential Equations, second edition work textbook. So this is the end of my discussion. I hope you enjoyed the lecture. Thank you for listening.